Alright, so again, I'm not really like a teacher or anything, you know, professionally or anything. I have taught a few friends, and they've always gotten a perfect score on all of their tests. So again, this stuff isn't really meant for you know, people you know, below like college, university, or older, you know. So let's see. So I wanted to go into like lightning mentally calculating like pi. So this is actually one of the rarest quote unquote abilities. If you have the capability of actually mentally calculating pi versus memorizing all of the decimal places of pi. But the thing is that there are actually different algorithms that create, that produce and output the pi decimal places. So I mean, you could. This is just one algorithm, right? Technically, this is an algorithm, and it has an infinite summation right here, right? So I'll explain that in just a minute. But there are actually different algorithms for calculating pi, and they write the algorithms and they program them into like a C++ application or different programming languages, and they'll have computers crunch the numbers, crunch the algorithms all day long to get the next few decimal places of pi to add to an extremely long pre-existing list of the decimal places of pi, right? So again, like I said, like before in the earlier videos, all of mathematics is actually just addition. It doesn't matter if it's subtraction. It doesn't matter if it's like higher order algebra or pre-ordered algebra or linear algebra or whatever, you know. It's all actually just addition. It's addition of perfect whole numbers and imperfect decimal numbers. That's all it is. So everything can be broken down into like little pieces, you know. So like, for example, like if you're using like PEMDAS or like BODMAS rules or something, you know, it makes it really easy to like solve even the most like complicated expressions and equations. And technically, like an equation is anything with like an equals sign, you know, at the most like fundamental level, you know. So obviously this is just like one algorithm, right? So this is saying that this is from this mathematician right here, or these mathematicians, but it's saying that 1 whole pi is equal to this, all of this right here, right? So in order to solve this like manually, what you would do is you would solve each part, right? So you're looking at the second exponent root of 2, right? So that's like the square root of 2, right? And it's a perfect whole. And then it's over 99 squared, right? So 99 times 99, right? So that'd be 8100 plus 810, so 8910, you know, 8910, and then whatever, you know, 9801, right? So you'd solve each part, right? And then you would divide, but you'd use like the PEMDAS rules, really that's all these are divisions. This is all division. But the thing is like with with this, of course, like you would just go back and you would like in my videos, there are going to be 100 videos, educational videos. So like in the Greek, they call it Greek mathematics. So it goes back to the development of math symbols in Greece early on, and then later on too, because later on, like much later on, after Greece and Rome, they changed what the meaning and definitions of what the Greek symbols mean in mathematics. So mathematicians actually changed it around later on. But now this is a sigma symbol right here, and this means summation. So this is a capital letter sigma. A lowercase sigma means something entirely different. It just depends on what kind of mathematics is being used in, but generally that's what it is. So, and then you have like the infinite